Here is question 3 of Unit 2 test on rates of change. I will like you to read the question, think about it, answer the question, and then see the video for the solution, okay? Now here is the question. Question number 3. Determine the zeros of f of x equals to x squared minus 3x minus 4 and estimate the instantaneous rate of change of f of x at the zeros. Okay, this is a knowledge-based question of 4 marks. You should be able to do it in 5 minutes. Okay, now first part is to find the zeros of the function, right? That should be easy. So zeros means your f of x should be equal to 0, right? And what is f of x? It is x squared minus 3x minus 4, which I can factor, right? We need product of minus 4 and sum of minus 3. So that is 4 minus 1, right? But 4 should be negative and 1 should be positive, correct? So you get 4 negative because minus 3, right? When you multiply minus 4 and 1, you get minus 4. And when you add minus 4 plus 1, you get minus 3. So you get plus 3, right? Now this factor tells you very clearly what are our zeros, correct? So let me write down zeros here on the side so that we remember them. So this function will have zeros at x equals to 4 and x equals to minus 3, correct? So these are our zeros. Now that's the first part. Determine the zeros of this function and estimate instantaneous rate of change of f of x at the zeros. Now to find instantaneous rate of change at more than one point, which method should you use? Right? You get it. So we will use that method, difference quotient, right? So rate of change, let me say rate of change is equals to f of x plus h minus f of x over h, right? Where what is h? H is something which is very, very small as compared to 1. In some of the questions where x is given to you, you can take h value as 0.001, okay? Here, we will first find a general solution and then plug in the values 4 and minus 3 to find instantaneous rate of change. We could do like that also, right? We could use 4 and 4.001 and then find instantaneous rate of change. You can also do like that, okay? Well, I prefer this. Okay, here it is. So we'll do f of x plus h for this function. So x squared will become x plus h whole square minus 3 times x plus h minus 4. So that is fx plus h. So let me write it in square brackets, right? Minus f of x, the whole thing, x squared minus 3x minus 4, correct? And everything divided by h. Perfect. Now we'll expand this. Let me write 1 over h here. I'll save some space. So here we have, if I write 1 over h, I have to make another brackets. Let me expand this. X squared plus 2xh plus h squared. And this is 3 times minus, right? Minus 3h minus 4 minus of x squared minus 3x minus 4. At this stage, what do you expect? You expect to cancel these 3, right? Let's look for them. X squared, minus 3x, minus 4, minus 4. Perfect. What are you left with? You are left with terms which have h in them, right? Perfect. So you can now factor out this h. So I'm going to factor out this h from the terms left. Let me mark those terms for you. This, this, and this. Just 3 terms. So I'm factoring out h first and then writing down the whole thing. So I got h over h, and so I factor out h outside, so I'm left with 2x. Is that okay? Plus h minus just the number 3. H has been factored out. Good. So h and h now can cancel out. That's the whole idea. When we do this difference quotient method, always this h and h will now be cancelled out. Okay, and you're left with 2x plus h minus 3. At times you'll find questions which will say give answer to 2 decimal places. In that case you have to use this to 2 decimal places. Otherwise you can assume this to be negligible, and at this stage write approximately 2x minus 3. So that becomes our estimated instantaneous rate of change. Okay, this point most of the students don't really get it when they are in the school, and they realize much later that this was always estimated instantaneous rate of change, right? Why estimated? Estimated because the next point is very, very close. H is very soon, right? But we can never be there, right? Very, very close. So always it will be estimated instantaneous rate of change, right? So let me say that is my formula for instantaneous rate of change at any point for this function. Does it make sense? It is 2x minus 3. Now you need to estimate instantaneous rate of change of f of x at the zeros. The zeros are at x equals to 4 and x equals to 3. So let's do it. So at x equals to 4, so let's do it for x equals to 4 and at x equals to minus 3, correct? Okay. Now at x equals to 4, rate of change, let me write like this. Rate of change at x equals to 4 equals to, we'll plug in 4 here, right? So it becomes 2 times 4 minus 3, which is 8 minus 3, which gives me 5. And here, estimate rate of change at x equals to minus 3 is equals to 2 times minus 3, which gives me 2 times minus 3 is minus 6, minus 3 will be minus 9. Correct? Now, that's the estimate rate of change at the 2 points. Now, does it make sense? Well, what we can do is kind of sometimes sketch our graph, right? Which is not important, especially in the test, right? But now, because I'm trying to make you understand things. This is a parabola which has positive leading coefficient. Therefore, it opens upwards, correct? So let's say this is a parabola which opens upwards. Now here in this parabola, we know we have x-intercepts at minus 3 and 4. So that means if this is my x-axis, this point happens to be minus 3 and that happens to be 4. Is it okay? So my y-axis will be somewhere kind of like this. Do you understand? Now slope here at minus 3 is negative. Yes, it is. So if I sketch a line here tangent to this, negative, and here is kind of positive. Do you see that? So if I touch it, go closer, like this, plus 5. So kind of we are right, at least from the sign point of view, correct? So these are our answers. So we have instantaneous rate of change at the 2 zeros. At x equals to 4, it is 5. And at x equals to minus 3, it is minus 9. Okay, thank you.